Okay, now here we are trying to see adversarial search problems. In that adversarial search problem, we have two type of examples. The first one is MiniMax problem. MiniMax problem that we are going to understand with the help of this example. Now, what happened in MiniMax problem? So, as we all know, in the adversarial search, there are two players in the game. One is try to maximize the utility function, and another, which is our opponent, try to minimize the utility function for its opponent. So, the Minimax is based on these two concepts. And we are looking for one of the solution here which is there in the form of some values. So what we have to do, we have to increase the utility score. That is our task. And this is a tree that is given. In each state, when we start from the root node, let's say we assume that in the root node you are the player, and after that in the next step the opponent is the player. After that again you are the player. In that way the two player game actually works. Now here we have a variable that we have to see, that is called v is the variable which is used in each and every nodes. Here these are all intermediate node. These node it called terminal node. Okay, so in the terminal node, we are not going to see any variable because we have some constant value here. So we'll not talk about the variable that we'll use in min-max. Now here in min-max, what we have to look is, we have to look that how we can increase the utility so that we can say we won the game. So we'll start with the root node. Root node is, you can understand that root node is you. After that your opponent will play the next move, then you will go to the next move. In that way it goes on. That's why it is a maximizer, then minimizer, and then maximizer. In that way it will go. Now as I told you, we have a variable v, and for maximizer the value of v will be initialized with minus infinite, and for minimizer the value of v will be initialized with plus infinite. So here for max the value of v will be initialized with minus infinite, and for min the value of v will be initialized with plus infinite. So we'll start the process from here. So we'll have a variable, and this variable is v here. So we'll start with v. The initialized value of v will be, because it is for maximizer, so we'll start with minus infinite. Now for minimizer, it will start with plus infinite. Now again for a maximizer, it will initialize with minus infinite. Now we have to traverse this tree in a in order fashion. In order means we have to go to the left node, then we'll go to the root node, and then we'll go to the right node. In that way we have to move. Now here if you'll see, if you'll go to the left node, so we are going to the left direction and we'll come in across the very extreme left. Now here we'll start the traversal. Now we have a value 4. 4 will give to this particular node max. And what max will do? Max try to maximize the value. So, and that value is v, that has to be maximized. Now the value is minus infinite. Minus infinite and this 4 will be compared. Whoever is max will give the value to v again. So this is the process of maximizer. Will give the maximum value to v. Now here if you see, this is infinite minus infinite and this is 4. So what is the larger value? Definitely 4 is the larger value. So 4 will be applied here. Now left portion has been done, root portion has been evaluated. Now go to the right. We'll go to the right, again we'll get the constant value. That constant value will take it and compare it again with the maximizer. So what is the maximizer value right now? Is 4. 4 will be compared with 8. Now who is larger? 8 is larger. So that 4 will be changed to 8. Now this portion has been done. So because this portion belongs to this node, what is the next traversal node for this node? Because we have done with left and root and then right, then because it is a left part, it will go to the root again. So what is the root? Root node is this one. So now it will give the value of v to this node. And what is the value of v? That is 8. Now 8 will be compared with this v. This v is positive infinite and we have to look for minimizer right now. So minimizer will minimize the value and look for the minimum value. So which is a minimum value, plus infinite or 8? So definitely 8 is the minimum value. So this particular plus infinite will be changed to 8. Now this root has been done. We'll go to the right part of it. Then we'll go to the right part of it. What is the value of v? So the value of v here is again initialized, because this is a max. It will initialize by minus infinite. Then we'll go to the left part of it, because we have to go left and then root and the right. In that way we have to traverse. When we'll go to the left part, we'll get the constant value 9. 9 will be picked up and compared with minus infinite. Which one is larger? Because we are going for the maximizer node. So larger we have to see, because minus infinite and 9. 9 is larger than minus infinite. So 9 will be changed to, minus infinite will be changed to 9. Again we'll do for the same thing with the right node also. So 3 will be coming here. 3 and 9 will be compared. Whichever is larger, 9 is larger, so 9 will be there. Now this portion has been done. What is the value that is going from here is 9. Now 8 we already have, 9 we got. So 8 and 9 will be compared. Whatever is minimum, that we have to put, because it is a minimizer. So 8 and 9, definitely 8 is the minimum. So 8 will come here. Now here, because this node has been traversed, we have to go to the root node. Which is a root node for that particular node? This is the root node. Now we'll go up. What is the value that it is going to put here is 8. Now 8 will be compared with the value of v. So v is here minus infinite. Minus infinite will be compared with 8. Where is maximum? Because it is a maximizer node. So minus infinite and 8, definitely 8 is the maximum value, then minus infinite. So 8 will be replaced by minus infinite. Now root has been done. Go to the right part. If we go to the right part, what is for the minimizer? Again, for the minimizer, initial value of minimizer will be plus infinite. So plus infinite will be the initial value. Then we have to go to a left part of it. So for the maximizer, what is the value of v? Definitely it is minus infinite. Now again left part, then we'll got the constant value 2. 2 will be fetched here. 2 will be compared with minus infinite. Whoever is maximum, because we are here looking for the maximizer. Who is max? So definitely 2 is the maximum value. So we'll put 2 here. Now again we'll go to the right part. We'll fetch minus 2. Minus 2 and 2. Whoever is maximum? Definitely 2 is the maximum. Now this part has been done. Then the value that we'll put here is 2. 2 will put here. Now we will be compared with 2. Whichever is minimum, positive infinite or 2, definitely 2 is less than the positive infinite. So that positive infinite will be changed to 2. Yes. Now again we'll go to the right part. From the right part again, what is max here? Max, for the max, what is the value of v? V is starting with minus infinite for the max. Now we'll go to the left part. 9 will be picked up. 9 will be compared with minus infinite. Whoever is larger, definitely 9 will be the larger value. So 9 will be replaced with v. Now go to the right part. Right part is minus 1. Minus 1 will be compared with 9. Whoever is larger value, 9 is the larger value, 9 will come. Again from this particular node, what value we have to send in the upper direction? It is 9. 9 will be compared with V. B is 2. 2 will be compared with 9. And we want minimum. Definitely 2 and 9, who is the minimum? 2 is the minimum. So 2 will be fetched from here. Now this is a maximizer node. 8 and 2 has come here. Whichever is max. So definitely 8 is max. So 8 is the value of V. So we got here a value from MiniMax procedure. We got the value, utility value, that is 8. And from where we'll get? We get from here in that particular direction. So first of all, when player will play its first game, it will move in that direction. Again, minimizer will move in that direction. Again, maximizer will move in that direction. In that way, we get the utility value. This is how we can do the searching in MiniMax search procedure. It is under adversarial search.